Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ about nucleophilic substitution reaction. And here you can see your question. You have to say what is the major product of this reaction, and four options are provided here. One of them is the right answer. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. And don't worry, after some time you will get the right answer with proper explanation. But remember one statement, self-evaluation is essential for improvement, and that's why you should try. I believe you have tried by yourself, so it's my turn to give you the right answer. Now, as usual, I suggest you student, please read the question carefully what is given. It is actually more than one step reaction. So, what is the reactant and what is the first step reagent? First step reagent is trimethoxyphosphine, and we know that phosphorus in +3 oxidation state has a lone pair of electron, and phosphorus is actually student a good nucleophile, okay, because this phosphorus is softer in nature. And if you look at the reagent, this is alpha bromo methyl ester. Okay, so this is the alpha carbon, and you know that alpha halocarbonyl, so this part is called alpha halocarbonyl, and alpha halocarbonyls are very good for SN2 types reaction because the transition state is stabilized by the -I effect of this carbonyl group. Now we have understood this much. So first step is actually an SN2 type reaction. So what happens here? So this lone pair of phosphorus can attack from the back side and it can open up. So if via SN2 process, it will produce this in product. See, phosphorus was neutral. So after this nucleophilic attack, this phosphorus will have a positive charge. Means it will be cationic, and adjacent to it, there will be this bromide anion. We know this bromide anion is good leaving group as well as good nucleophile. Since it is a good leaving group, so it left efficiently, and now it is also a good nucleophile, so it can attack here from the back side. So what will happen? Oxygen will have a positive charge and it will come and form a double bond with phosphorus, and then this positive charge on phosphorus will be neutralized, and phosphorus will form a phosphorus oxygen double bond. Now question, why this double bond formation possible with phosphorus oxygen? There are two reasons. Because phosphorus can form stable d pi p pi back bonding with oxygen, means p pi of oxygen and d pi of phosphorus. P pi is filled of oxygen and d pi for phosphorus is vacant. Okay, so that's how this double bond formation is possible, one point. And second point is student that phosphorus can extend its valency from 3 to 5 because of energetically accessible vacant orbital. So this is, I guess you have understood. So it will be produced, and this is called Arbuzov reaction. Now in the next step is given base and aldehyde. Base means sodium methoxide, and sodium methoxide is significantly strong base. And I suggest you student, please look at this part of the molecule. Can you remember anything? I guess yes, this is 1,3-dicarbonyl compound or active methylene compound. I have already discussed many lectures about this, and we know that these active methylene compounds have acidic protons which could easily be abstracted by base, because the produced carbon ion means here, so after this abstraction, this produced carbon ion is resonance stabilized. How? So you can consider that it could be resonance stabilized either by this carbonyl, one option. Another option is it could be stabilized by with this phosphorus double bond also. Fine. So it's stable. Not only it's stable, it is nucleophilic, because carbon ion is actually softer in nature, so it can act as nucleophile. And here there is one ketone which is electrophilic in nature. So obviously find nucleophilic addition reaction possible, and it will produce this O-. Now sometime before I told that phosphorus can form stable bond with oxygen because this bond have in extra stability due to d pi p pi back bonding. So in this case here you can see that oxygen is carrying a negative charge O minus, so it can attack this phosphorus center and it can open up. Now you can say that, sir, why it is a 4-member ring formation? Yes student, I agree, but remember size of phosphorus is more, so the angle strain is relatively less. So here you can expect that there are 2 OMe phosphorus, so here there is a chance of, this is oxygen, this fine pH, and other part is as it is. So I guess you have understand this, and here O minus. Okay, so in the next step what is possible? See, there is one phosphorus carbon bond, but phosphorus carbon bond is not that much stable like phosphorus oxygen bond, so bond exchange will occur. I guess you have learned this Wittig type of reaction, so same thing is possible. So you may expect that it can push, it will come, and it will open up. This, or you can explain this thing in different way also, that it can come and it can go. So both are correct. And in this way, look at student, this organic part, it will be alkene, means here carbon carbon double bond, or if you more specifically want to know, this is alpha beta double bond. So alpha beta alkene derivative will be produced in this reaction. Okay, so this is the product. Now if you look at this alpha beta double bond, obviously yes. Okay, now if this question is given, so this is the answer. Now if this question is given in your exam less than 30 seconds, how can you conclude what will be the product? Student, for that purpose you should have enough knowledge on name reaction. This first step reaction is called Arbuzov reaction, and I think student you should go stepwise here. You should draw the product, and later on, means draw the product means after Arbuzov you can seriously understand that okay, this is OMe twice phosphorus double bond O, this is CO2 Me, means it's an active methylene compound. So first of all here it will be a carbon ion in terms of NaOMe, then nucleophilic addition with ketone, and phosphorus oxygen bond formation stable, so alpha beta unsaturated carbonyl derivative will be produced. Fine, but dicarbonyl formation not possible, because here only one carbonyl is given student, so option D gone. Another thing, alpha beta unsaturated carbonyl, not active methylene compound, so this is gone, and it is student a single ketone. No, that's not possible, it's also gone. So what is left? Option B. So this is the right answer. So based on this logic, knowledge and understanding, you can come to the right answer very fast. But remember, practice is essential along with this also. Now in conclusion, what you have learned today, that in Arbuzov reaction the trivalent phosphorus center can act as nucleophile and it could be converted into pentavalent phosphorus derivative. This phosphorus lone pair of electron is better nucleophilic due to its softer nature, bigger, softer in nature, and phosphorus bond oxygen bond is stronger due to d pi p pi back bonding. Means this phosphorus oxygen single bond have some partial double bond character because of this type of bonding. Now active methylene compounds are significantly acidic due to resonance stabilization of the carbon ion or conjugate acid, means conjugate base, means from acid to the abstract proton is conjugate base. Now carbon ion from active methylene compound can act as nucleophile and it results in Knoevenagel type of condensation. Actually everything is a variation of aldol condensation. Here carbon ion is acting as a nucleophile and reacting to attacking to another carbonyl carbon which is electrophilic in nature and result in alpha beta unsaturated carbonyl derivative. So this is the end of this discussion. I believe this video may be useful. Please write your opinion in the comment box, and if you consider my contents unworthy, then please help this channel to grow. And if possible, please visit my another channel and see you in my next video. Stay happy.